All right, let's dive into one of the most fundamental ideas in all of artificial intelligence, the simple reflex agent. Now that might sound a little fancy, but trust me, this is ground zero, the very first step on the ladder to creating the kinds of smart AI we hear about all the time. And the key to understanding it all, well, it starts with something surprisingly human.
So let me ask you a kind of weird question. What on earth could a sneeze possibly have in common with an AI? It sounds like a joke, right? But the answer to this is actually the key to this entire topic.
And the answer is an instant reaction. Think about it. A sneeze has no thought, no planning. It's just an immediate, totally automatic response to something, right? And that exact idea, that pure reflex, is the foundation of the very first type of AI we're going to break down.
To really get this, we're actually going to start with us, with the human equivalent, because if you can understand your own reflexes, you're already halfway to understanding how a simple reflex agent works.
Yeah, think about that sneeze again. It's totally spontaneous. You don't sit there and calculate the pros and cons of sneezing or check your sneeze history to see if it's a good idea. Or, when you touch a hot stove, you don't think, you just pull your hand back. It's an action without a past, based only on what's happening in that very instant. That's a pure reflex.
Okay, so we've got the human version down. Now, let's meet its digital twin. It's time to see how this simple concept of a reflex gets built into an actual AI.
So here's the official definition. A simple reflex agent acts only based on what it's perceiving at this very moment. It doesn't care about what happened before, and it's definitely not thinking about the future. Its entire world boils down to one simple question. What's going on right now?
And this right here is the most important part. This agent has literally zero memory. It doesn't learn from what happened yesterday or even 5 seconds ago. And there's a really good reason for this design. By ignoring everything that's ever happened, it can act incredibly fast. If it had to stop and process the past, it'd get bogged down. It wouldn't be a reflex anymore.
So you're probably wondering, if it has no memory, how does it know what to do? Well, the answer is almost ridiculously simple. Its entire brain, its whole logic, is built on what are called condition-action rules. But really, they're just basic if-then statements.
And what's kind of wild is that this is it. This is the entire thought process. If I see this, then I do that. There's nothing more to it. It's just a direct, hardwired connection between what it senses and what it does.
Okay, so we've got a really simple agent with a really simple rulebook. So logically, you can probably guess that it can't just work anywhere. For an agent this basic to actually be useful, it needs a very specific kind of environment to live in.
And that perfect world is called a fully observable environment. All that means is that the agent can see everything it needs to see to make the right decision in that exact moment. No hidden information, no surprises, no guesswork.
And this slide lays it out perfectly. On the left, you have a fully observable world, like a game of chess. The agent knows exactly where every single piece is. It has all the information it needs right there on the board. But on the right, in a partially observable world, like a real road, a self-driving car has no idea what's just around that blind corner. And that kind of hidden info, that complexity is where a simple reflex agent just completely falls apart.
All right, let's make this way more concrete with a classic real-world example. Let's pretend our simple reflex agent is the tiny brain inside your home thermostat.
So before we look at its specific programming, just remember its simple three-step dance. First, it senses the world. What's the temperature? Second, it finds the if-then rule in its programming that matches what it's sensing. And third, it executes the action. Sense, find, do. That's the entire loop.
And here it is. This is the agent's entire brain for this job. This one single line of logic is its whole purpose in life. If the condition is true, the action happens. That's it.
So let's watch it work. The sensor picks up that the room temperature is 46 degrees. It checks its one and only rule. Is 46 greater than 45? Yes, it is. So the condition is met, and bam! It immediately executes the action. Switch on the AC. Instantaneous. No thinking required.
Now in that little scenario, it works perfectly. But, and you might be seeing this coming, this beautiful, elegant simplicity has a major, major flaw. Because simple, as it turns out, isn't always smart.
And here's the fundamental problem. That rule is absolute, and it has zero context. So what if nobody is even in the room? The AC still clicks on, wasting a ton of energy. Or what if the person inside is elderly and is already shivering? The agent doesn't know, and it doesn't care. All it knows is its one simple rule. And this gets us to the agent's biggest limitation. It's brittle. It just can't handle any real complexity because it has no context. To solve that empty room problem, you'd have to start adding more sensors, more rules, and pretty soon you're not building a simple reflex agent anymore. You're starting to build a more advanced AI that can create an internal model of how the world actually works.
And this leaves us with a final kind of mind-blowing thought to wrap this up. We've just seen how the most basic form of AI can get tripped up by something as simple as an empty room. So just try to imagine the incredible leap in complexity it takes to go from this fundamental building block to an AI that can navigate the chaos of a busy, unpredictable city street.